Cosmologists will tell you, with a straight face, that the universe appears to be flat, which sounds ridiculous, because you can see it is not a pancake. So let me explain what that word actually means, because the real version is much stranger. Flat here has nothing to do with thickness. It is a statement about geometry, specifically about what happens to straight lines and to triangles when you draw them across enormous distances. There are three possibilities for the shape of space overall, and they are genuinely different worlds to live in. The first is flat space, the geometry you were taught in school. Parallel lines stay exactly parallel forever. Draw a triangle, add up the three angles, and you get 180 degrees. Every time. The second is positively curved space. Think of the surface of a sphere. Draw a big triangle on a globe, and the angles add up to more than 180. The sides bulge outward. Positively curved space also does something wild. Set off in a perfectly straight line, never turning, and eventually you arrive back where you started. Space like that closes on itself. It is finite, with no edge. The third option is negatively curved space, shaped a bit like a saddle or a Pringle, in every direction at once. There, triangle angles add up to less than 180. And on a saddle, lines that start out parallel gradually spread apart. Space like that keeps opening up forever. So those are the three menus: flat, sphere-like, or saddle-like. The obvious question is which one we actually live in. And the wonderful thing is that this is not philosophy. It is measurable. The method is exactly what you would guess. Draw the biggest triangle you possibly can, and go measure its angles. But there is a catch. To do that, you need something out at an enormous distance whose real size you already know. A cosmic ruler. And for a long time, nobody had one. Then we found one. In the oldest light there is, the cosmic microwave background. It is the leftover glow from when the universe was about 380,000 years old. That glow is not perfectly smooth. It has faint hot and cold patches, and those patches are frozen sound waves. In the hot, early universe, pressure waves genuinely rippled through the plasma, like sound through air. Those waves could only travel for a fixed amount of time before the universe cooled and the pattern froze in place. Which means the patches have a known physical size. That is our ruler. So now the experiment is simple to state. We know how big those patches really are. We know how far away they are. So we know exactly how large they should appear in the sky, if space is flat. And if space is curved, the light traveling to us across billions of years gets bent. Positive curvature magnifies the patches and makes them look bigger. Negative curvature shrinks them. So we point a telescope at the oldest light in existence, measure the patches, and compare. It is a triangle billions of light years wide, and we are measuring its angles. The answer, from the WMAP and Planck missions, is that the patches come out at the flat space size. As best we can measure, space is flat to within about 0.5%. Which is a fantastic result, and also deeply suspicious. Because flat is not a comfortable thing for a universe to be. Flat is a knife edge. It is the exact boundary between the density that recollapses and the density that flies apart. And crucially, any tiny deviation from it grows over time. It is like balancing a pencil on its tip. Finding one still standing after 14 billion years does not make you think you got lucky. It makes you think somebody is holding it. For the universe to look this flat today, it had to start out unbelievably flat. We are talking agreement to within many decimal places in the first instance. That is the flatness problem. And the leading answer is a theory called inflation. In the very first fraction of a second, space is thought to have expanded by an absolutely absurd factor, doubling over and over. And stretching does something specific to curvature. It flattens it. Take a beach ball and inflate it to the size of the Earth, and the patch in front of you now looks perfectly flat, even though the whole thing is still a sphere. Which is the real punchline. Inflation does not say the universe is flat. It says that whatever shape it started with, the piece of it we can see got stretched so enormously that it looks flat to us. So is the universe infinite? Flat certainly allows it. But flat does not force it. Space could be flat and still wrap around on itself, the way the screen in an old arcade game does when you fly off one edge and reappear on the other. It is also worth knowing that geometry used to be destiny. For decades, the shape of space was thought to determine how everything ends. Then dark energy showed up and broke that neat link entirely. And the honest caveat, every measurement has error bars. Flat to within 0.5% leaves room for a very gentle curve we simply cannot detect yet. Flat is the best fit we have, not a closed case. So the universe might be flat, might be gently curved, and is definitely stranger than a pancake. If you enjoyed that, subscribe to Curious Doodle and go draw a very large triangle.